us discuss about ionization energy and excitation energy. So till now we have derived about the energy of various levels inside the atom, and these energies have got a very specific amount and they are very discrete, that we have learnt. And also what we have seen that from nucleus, if this is the nucleus, the levels which are close to the energy levels that are close to the nucleus have got the highest amount of energy, and far away from it gets lesser and lesser. So if we look this whole thing from another perspective, as the energies are bound, it means they are negative in sign. So what we see that in negative, if you consider this negative sign also, then this is the least energy. So minus 1.5 is definitely greater than minus 13.6. So if we consider only the numerical value, then definitely what we see, as we are going far away from the nucleus, the energies are actually decreasing. But if we consider the negative sign also, that we see that this is the least energy, because this is minus 13.6, and then this is the higher energy and this is the higher energy, and so on. So these are called the higher energy levels, and close to the nucleus these energies are called very least amount of energy level. So if I just talk about the first energy level, if this is the nucleus, then the first energy level for hydrogen, it is 13.6 electron volt. So this first energy level, where the energy is least, we call it as normal state or ground state. Normal state or ground state of energy level, because here if you consider the negative sign also, the energy level is the least. Now when we are talking about the ionization energy, you just think, what is ionization process? The ionization process means to remove an electron from the atom, and if we remove it, we have to remove it from the ground state. So when we are removing from the ground state an electron, then it just cannot happen on its own. We told that from a higher energy level, electron can automatically by itself radiate certain energy and jump to the lower energy level. But if we have to remove an electron which is already in a stable orbit, then we need to provide certain amount of energy for the electron to come out. Suppose the electron is in ground state, for the electron to come out, we need to provide certain amount of energy. And why so? Because this electron is bounded to the nucleus. There is a kind of attractive force that is working on between the electron and the nucleus. And if the electron has to be freed from this attractive force and this bound state, it needs to get certain energy, and we need to provide certain energy to knock the electron out from this bound first state, that is the ground state. And the energy needed for doing that, what we call it as ionization energy. So you can remember it from the ionization process, that the ionization process is to knock out the electron from an atom, and the electron has to be knocked out from the ground state. And therefore if the electron has to be knocked out, we need to provide certain amount of energy, and that energy is called ionization energy. So to ionize the atom or to knock out the electron from the ground state, whatever energy is needed, we call it as ionization energy. This energy we can depict this energy in any of the units, but if the energy provided, if the ionization energy, if we denote it with electron volt unit, that is, here the volt or the potential come into the picture. The electrons can be knocked out with the potential V, that is electron volt unit, if we are trying to show how much of energy is needed, then that particular calculation for the electron with the potential needed to remove that electron from that, then when that energy we depicted with electron volt unit, we call it as ionization potential, because here we are also depicting in terms of potential. So the same ionization energy in terms of potential, we call it as ionization potential for the electron with a potential V, right? So this is what is ionization energy and ionization potential. Now coming to the excitation energy, before that, if I have to calculate ionization energy for suppose hydrogen, so hydrogen at the normal state, I mean, or at the ground state, the hydrogen has energy minus 13.6 electron volt, right? So if we have to knock out this electron from the ground state, we need to provide this much amount of energy to knock out that electron. So for a ground state electron at hydrogen atom, the ionization potential will be 13.6 electron volt, right? Now coming to the excitation energy. Excitation, you understand just by the word excitation means exciting any electron from a lower level to a higher level, right? So in Bohr's postulate, we know that for an electron to jump from higher level to lower level, we don't need to provide any energy. Electron can just release itself certain energy and can jump to the lower level. And from the spectral series, we have seen that from any of the higher level, electron can jump any of the lower level. So when coming from jumping to higher level to lower level, it can happen. But when it is that the electron has to be pushed to a higher level from a lower level, that process we call it as excitation process. So in excitation process, definitely we need to provide extra amount of energy to move it from this level to that level. Suppose for a hydrogen, this is n equal to 1, that is ground state. This is n equal to 2, that is the first higher orbit. So from ground level, if the electron has to be pushed to the next level, whatever amount of energy is required, that energy we call it as excitation energy. So if we just calculate what would be the energy required from the Bohr's, this one is minus 3.4 minus of minus 13.6, means what we are doing, E2 minus E1, this is the amount of energy we need to provide to this electron to move from minus 13.6 electron volt to minus 3.4 electron volt, that is E2 minus E1. So E2 is the final state, E1 is the initial state. So final state is minus 3.4 minus initial state is minus 13.6 electron volts. Then we can write minus 3.4 plus 13.6. So this is around 10.2. So around 10.2 electron volt is required to excite an electron of hydrogen from the ground state to a higher state. So this is what is called the excitation energy. And here again, when we have represented it electron with the voltage or potential unit, then we call it as potential, excitation potential. So here we have seen that the ionization potential is around 13.6 electron volt for the ground state atom, and excitation potential is 10.2 electron volt. This is the energy that we need to provide for the electron to move from ground state to higher state inside the atom only. Whereas the ionization potential is the energy that we need to provide for the electron to just come out of the atom and thereby ionizing the atom. So as we have learned about the kinetic energy of the electron inside the orbit, potential energy inside the orbit, so there are two other very important concept of the energy that we are learning here. One is ionization energy or ionization potential, and excitation energy or excitation potential.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.